This is a small getting started video about MemCP, and the URL of MemCP is github.com/launix-de/memcp. And when you take a look at the features of the MemCP, it is a fast in-memory database, so you can write your applications and just make them perform better. MemCP uses in-memory compression, so it will use very, very few memory. And it will also use multi-core architectures and is cache optimized and so on. I will show you a bit around. Like, we go to code, then we copy the URL, and then we clone it. So there we are. It is written in Go, so we use the Go build system. But before we can do Go build, we have to Go get. Now we have created we have compiled the file MemCP. It is about 8 megabytes, so it's really slim. And now we can execute it. And MemCP is licensed under GPL 3, so it's completely open source. You can change it, you can improve it, you can use it. You can use it in commercial ways, you can use it for your hobby projects, you can use it everywhere. And what this process does, it starts up the memory database and then drops you at the scheme shell. Now there are two ways to connect to the database. One is over the REST endpoint on port 4321, and the other one is on port 3301 with a MySQL protocol. There are more protocols coming, like MQTT for industrial systems and so on, but let's try with the MySQL protocol. So MySQL, I switch to port 3307. So 3306 is MySQL and 3307 is MemCP. User is root and password is admin. P and now admin. Enter. Now we are in the database. We can switch the database to system. Show databases. There we have only the database system in the moment. Show tables. There we have the user table. Select star from user. And there we have root with an encrypted password. Okay, let's create a database. Show databases. Now we see the databases listed. We can switch to test. Show tables should be empty. Now create table friends. Name string, age int. Show tables. Okay. Insert into friends, name, age, values. Ulf 35. Gisela 87. Now we can do select star from friends. And we can say select star from friends where age smaller 40. Now they have their birthday, so we can say update friends set. By the way, set age equals age plus 1. And there we got our first error. So you see it's still in development. But you can also see it's quite nice. Some SQL-ish things. Now, that was the SQL frontend. The REST frontend works similar. We just have the root call localhost. Now we have to say root admin at localhost at 42.1 SQL/test/show tables. And we have to escape. And there we get our queries. Select star from friends. So, the REST API works in JSON-L format. So, JSON-L means it is new line separated format, and every line contains a JSON object with a result. Now let's go to MemCP shell back again. What is this? This is Scheme. Scheme is a functional programming language, and you can type help. And Scheme in MemCP has some built-in functions, and I will show you how they work. There are some arithmetic functions like plus, minus, multiply, and a lot of operators. They work as follows. You say a round bracket, then we say our operator, so our function, plus 1 and 2. So the parameters are separated via space, and this will yield 3. 1 plus 2 is 3. And there are also string functions to concat strings, to put them in upper or lowercase, to replace things, to split strings into arrays, like split I am the best with space, and there we will get an array with I am the best. There are list functions. The list functions are mainly just took over from Lisp. So const char setter, const creates a list from a header and a rest list. So it works like a linked list, but internally it's not stored as linked lists, because a pointer on a 64-bit system is really costly, and so we avoid pointers wherever we can. Char extracts the head, setter extracts the rest of the list, so we can do self-recursive functions that go like a for loop over the data. And then we have filter, map, reduce. And these are the basics how MemCP works. So filter gets an array and a condition, and it will filter out. So let me show you. Filter, we have the list 1, 2, 3, 4, 5, 6, 7, and we say the condition is now we build a lambda x where smaller x4. So this basically means function x return x smaller 4. It's very similar to JavaScript. And this will filter out the elements that are smaller than 4. Next in our tutorial is map. So we can say map 1, 2, 3, 4, 5, 6, 7 with lambda x plus x and 1. So return x plus 1, and then we get the list 2, 3, 4, 5, 6, 7, 8. And now the last one is reduce. And reduce is very smart. And in this case, I am having a error here. So how to read errors? Panic prompt function reduce expect parameter 3 to be func, but found value of type number. So if I don't know how a function works, I just say help reduce. And there we have an error in our documentation. So let's fix this error. Let's fix this error. Reduce, the third parameter is of type any. Now, help reduce. Go build. Help reduce. And now it's in the correct thing. You see I stopped the engine, but now I can just do arrow up and recall my old inputs. Now, what does reduce do? Reduce takes a list, a function with 2 parameters and a neutral element. And this plus you have, it's like lambda a and b with plus a b. So it takes 2 parameters a and b and then adds them both and returns the added value. So a is filled with the accumulator and b is filled with the first value. So at first it says a b. So let's make it visible. Begin. I make a begin around it and I say print a equals a, b equals b. And now you see a is 0 and b is fed with 1. Then a is 1, b is fed with 2. A is 3, so 1 plus 2 is 3. B is fed with 3, so we get 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7 is 28. So that's how reduce works. And basically all database operations are just filter, map, reduce patterns. So let's go back to the help. And we have the storage, and the storage has a function scan, and scan is our map filter reduce, our parallel map filter reduce function on a database data. So help scan. If you want to build any applications with MemCP, you just have to learn how scan works, and then you can build all your applications directly on it without using SQL. So help scan, what does it do? It takes 4 to 6 parameters. The first is the database name, the second is the table name to scan. Then we have a filter function. Then we have a map function, and we have a reduce and a neutral. But reduce and neutral is optional. So let's say we want to know how to compile select star from foo. So select star from fans. So I have this function parse SQL test select star from friends. And what does this parse SQL do? It takes a database name and a SQL snippet, and it compiles it down to scheme. So every scheme data can also be scheme code. And that's the advantage. So we can do JIT code wherever we want. And it calls scan with test and friends, so a database and table. The condition is lambda true, so always take the items. And the map function is lambda name h, result row name hh. Result row has to be defined by the caller, so we say set result row to print. And then we can execute our function. And we have no inputs, but we can change this. Parse SQL test insert into friends. Just copy insert into friends Isela and Ulf. So let's see how this is compiled. This is a begin statement with 2 inserts. Insert test friends name Ulf age 35. Insert test friends name Gisela age 87. If I execute this, the thing is stored into the database, and now I can scan. And now I get name Ulf, age 35, name Gisela, age 87. These lists have a special pattern. They are always key value, key value. This is a very compact storage of dictionaries. And if you go to the help, you have this help topic about associative lists. And you can do all things of them, like group them or merge. Merging is used for the group operator in SQL. A set will change a value. Merge will do the grouping. Extract will turn the map into a list, and so on and so on. Now let's test a different SQL snippet. Let's say parse SQL test select star from friends where age is smaller than 40. And this will compile with just one difference. It will say the condition is lambda h smaller age 40. And you see these lambda for the filter, these lambda expressions for the filter and the map function are directly using the column names as parameters. And that's exactly the advantage of columnar databases. you only have to open those columns that you're actually reading. So in the filter phase, we only need to look at the age, and we can also like make a index on the age. And in the map phase, we have to load these two columns. This is especially advantageous if we only want to sum up one single column and filter after another column instead of having to read possibly hundreds of columns in a data set. So what to try next? We have some internal functions like stat. It will print out the statistics. So 0 megabytes allocated. There we can see how well our memory is occupied. And we have a function rebuild. And rebuilding is optimizing the storage. So if we call rebuild is automatically called normally. If we call rebuild, the system is rebuilding the shard for table friends. So it has optimized the memory layout of this table. And the column name is stored as a string dictionary with 2 entries. And the age is stored as a 6-bit integer. And now if we scan over our friends, let's parse. Now if we scan over our friends with the age filter, that's the one thing. But let's test an equal age 35. If we execute the equal filter twice, it will automatically build an index on friends over age. So the database has on itself figured out what index to use on this database to make the queries as fast as possible, and you don't have to care about anything. You just have to write this scheme code, this functional code, and the compiler examines the structure of your formula and tries to find data structures where you can store the data effectively, efficiently. I think that's a good point to stop here. Please go to github.com, launix.de, MemCP, clone the repository, fork yourself, make changes, expand the SQL, the supported SQL syntax, optimize the algorithms. Next time I can show you the algorithm for the ordered scan. So if I go to help, we have 2 types of scans. There will be, in total, there will be 3 or more scans, but at first we have the scan. It's an unordered parallel filter memory use pass, and scan order is an ordered pass with a parallel filter, but a serial memory use pass. So this means if you have order by limit clauses, let's recall the help for it. So if you have something like sort columns, sort directions, so like ascending and descending, and offset and limit, the function scan order is the right one for you. It's a bit slower because it cannot work in parallel, but it will guarantee you the correct order of your items. And the algorithm behind this is very, very interesting and sophisticated. So keep in tune. Also, please star and watch the repository so you get notified when something changes. And I hope we see each other again.